Hello everyone, this is Anjali. I am here with my colleague Shrita from AquaBSafe team to present our idea to NIRMAAN. We want to develop a device using microbial desalination technique to soften hard water. So as we all know, water is essential natural resources for sustaining our lives. In a country like India, groundwater forms a major source of drinking water in urban as well as in rural areas. More than 90% of the rural population in India uses groundwater for household requirements. Also, groundwater caters to more than 50% of urban water requirements. But in many areas, this groundwater is found to be hard water. Hard water results from naturally occurring weathering of limestone, sedimentary rock, and calcium-bearing minerals. It can also occur due to chemical and mining industry effluents or excessive application of lime to the soil in agricultural areas. Hard water is known to have harmful health effects like gastrointestinal problems, kidney stones, constipation, etc. So it also has deleterious effects on the water infrastructure like pipes, water tubs, sinks, and other household ware. So major problems are being faced in certain parts of the country due to the presence of excess fluoride, arsenic, and nitrate in the groundwater. According to a study, nearly 66 million people face the risk of which an estimated 6 million are children. Long-term ingestion of this drinking water having fluoride beyond a limit of 1.5 ppm leads to dental and skeletal fluorosis as well as non-skeletal manifestations. Fluorosis has no treatment and is known to be a deadly disease. It is unfortunate that many people are unaware of this consequences. Non-availability of municipal water, groundwater contamination, and health awareness have increased the potential for water treatment market in commercial and residential segments in India. Water treatment methods available in the current market are lime softening, reverse osmosis, and ion exchange process. These processes have their own drawbacks when it comes to usage. For example, lime softening involves production of high volume lime sludge stream and use of chemicals such as quicklime, coagulants, soda ash, and acids for adjusting pH. Other methods of water softening include nanofiltration, electrodialysis, carbon nanotubes, capacitive deionization. These processes, though effective, consume high amounts of energy and their operation is also costly. Therefore, there is a significant need to develop an environmentally friendly, cost-effective and low-energy consuming process, which would be an ideal addition to the water softening market. Now, my colleague Shrita will present to you about our solution.
We came up with a solution to this. Our idea is to develop a cleaner and cheaper method to soften hard water. We want to devise a setup for the same using the principle of microbial desalination sets. Our device is also designed to remove heavy metal and fluoride content present in water. Here is a brief description of how we will go about this. As shown here, the setup has 3 chambers: an anode chamber, a chamber for hard water or drinking water treatment, and a cathode chamber. The chambers are separated by anion exchange membrane and cation exchange membrane. Water with high organic content, for example wastewater, is supplied in the anode chamber. We want to use an open air cathode as a substitute for ferricyanide being used in the existing setup. Membranes and electrodes majorly contribute to our costs. A biofilm of microbes isolated from wastewater is established on anode. Electrons from respiratory chain of the microbes are transferred to the anode and current is generated by connecting anode and cathode. Due to the current, cations move to cation exchange membrane and anions move to anion exchange membrane. The resulting water has decreased concentration of these anions. One key issue we might be facing is disinfection of treated water as microbes are being used in the setup. Moreover, it is a time-consuming process. Issues related to scale-up might also arise. Once the setup is successfully developed, we want to target markets at both household and community levels. Later, we might focus on making our product available in rural areas that lack basic water treatment facilities. We hope to make an impact on the society with our product by providing basic water treatment, thus solving the problems of groundwater contamination in a cleaner and cheaper way. Thank you. Here I conclude our presentation.